Yeah. Okay, so let me repeat it for the recording. So we're the rules that are described in the course project. So each team has 15 minutes for the presentation, and up to 10 minutes after that we have for questions from anybody. And you get 40% of your course project mark for the presentation, and the remaining 60% for the code and the report. And out of this 40% for the presentation, 16% is business pitch, 12% is content, and 12% is organization and delivery. Two of us, Volodymyr and I, are giving you the marks, and after that you get the average of the two of our marks for the presentation part, while the code and reports are marked by Volodymyr. So any questions, suggestions before we start, or should we still wait? Well, let's start at probably 14:05, so that everybody who is a bit late has a chance to join. And in the meantime,
one question about the marks. So will we receive our total mark today or tomorrow, or where? When?
So I don't know if it makes sense to share the marks for the presentation, but Volodymyr should mark the code and the reports by January 20th. So I don't know if he started the marking or not. So, but yeah, we can ask him. So you'll probably get your total marks at the latest on January 20th.
Thank you.
Thank you. I don't know if Moodle allows you to see this, to get partial marks today, and after that the remaining marks later, but we'll see. Okay, so while we are waiting for a couple more minutes, the first team to present is novels, literature, and poems. And the guys, feel free to share your screen and just get ready, and we'll start in 2 minutes. Oh, perfect. Everybody can see a screen, and you can test your audio as well.
Yes, I think you can hear it.
Okay, so now 1 more minute for everybody who is still wants to join. And another announcement. Yeah, we have this competition presentations for Tula as a seminar of the Shevchenko Scientific Society of Canada on January 29th. So I hope that all teams will decide to participate in the competition and compete for the first prize of 1,000 Canadian dollars, second prize of 500 Canadian dollars, and third prize of 300 Canadian dollars. Those presentations are open to public. Presentations are in Ukrainian, but you can use the same slides that you have prepared for the course project, slides in English. So you still have a couple of weeks to change something if you want for the Toronto Ukrainian Library Association competition. But I hope that all teams decide to participate in that, because that's really an interesting topic. And I hope that all of you had, in addition to learning data science, learning how you can open on a practical project, that all of you had fun. And hopefully it was not too stressful to work on this. Okay, now let's start. The first team to present is novels, literature, and poems. So please.
Hello, everybody. Thank you for the introduction. My name is Irina Bondarenko, and I represent now the presentation of our team, Novels, Literature, Poems, acronym is NLP. And here is members of our team. It's Katerina, Roman, Alexandra, and Andriy. In our research, we have analyzed children's literature published by Ukrainian diaspora in the 20th century. Yes, so about the project in general, the main goal of the project was to define the ideas in children's literature specifically, from the books published in the 20th century outside of Soviet Ukraine. And for that, we use the Toronto Ukrainian Library Association book repository given by this link. The research questions for our project are the next. First, what are the topics in the whole data set and in a smaller subset of diaspora and children's literature? How did the wording of children's literature change over decades? What are the sentiment approaches in the children's books, and are they mostly negative, positive? And if there is a sentiment coloring related to the specific topics that we define on the previous steps. We also, 2 members of our team also worked on the classification and clustering, and they will speak about it after I present the preprocessing and the data set. So the data set, the total data set contains a little bit over 2,500 books recognized. And for clustering, we used all books, and for classification, we used only Ukrainian books written in Ukrainian language. This is exactly 2,500. And the children's literature, which was defined as a children's literature initially in the original repository, it was nearly 80 books. The preprocessing included, generally, I must say that we had slightly different preprocessing methods for each member of the team, but in general, it was like this. First, punctuation removal, converting everything to the lowercase, remove the stop words, tokenize the words. Some members of the team did lemmatization, some others did stemming. And for classification specifically, this member of the team, Andriy, transformed the initial classification labels for the purposes of his research. And now Andriy will speak.
Thank you, Irina, for the intro. So as Irina already mentioned, for classification, I have used only Ukrainian books, and to be precise, 2,498 books. Participated in the training and testing of the classification model, and it's after stripping of the data set from the donors in the classification labels. I have used also a slightly transformed version of initial classification labels, namely the first label in the book classification was used for training and testing. And it's because it yielded slightly better results rather than if classification labels would be used as is. And plus the plot would look nicer, and we will go to that a little later. So speaking about classification algorithms, I have used 2 algorithms primarily. It's naive Bayes classifier, NBC, and stochastic gradient descent, SGD. As you can see, SGD accuracy was has a better accuracy, 69%. And the confusion magic reveals what number of the books the model predicted on the horizontal axis, and what actually was the book label on the vertical axis. The intensity of blue implies how many samples of each label have been participating in the prediction. As you may have already noticed, prose was the most correctly predicted label by both models, perhaps due to the large sample representation in the overall data set. And speaking of recommendations on how to improve the model and save the Tula budget on librarians and other specialized staff who would manually classify each book, you will hear it in the end of our presentation. So stay tuned. And Roman, please kick off with clustering.
Yeah, hello everybody, and thank you for introduction. So, like, my part of the work was related to clustering of the whole data set. Like, it's in contrary to the another part of the team who were working with a subset, and especially specifically with children books. So the model I've decided to use is like the most simple model. It's a k-means, but actually it gave a rather good results, because clusters that I've got from this data set, they were really well specified, and it was easy to identify what cluster is about. So actually it involved like processing of about 2,500 books, as very similar to Andre's like processing. But the interesting part is that I've decided not to use like systematization. Actually, I've tried it, but it gave like it gave not like the best results. So here you can see like the word cloud for the whole data set. And because like I haven't used systematization, you can see a lot of words with a Ukraine with Ukraine root, so Ukraine, Ukrainskaya. And actually, please can you like yeah, and here's the main topics. Four of them are ordered in the descending order. So the most popular is like family, then is USSR in industry. So actually USSR and industries are quite related in these books. Then we have like culture, rural life, a lot of like words about animals and so on. And the last topic I've decided to like present here is art and science. So that's and the further research, like it could be possibly like you could possibly use another clusterization algorithm, but I'm not sure like whether it is needed here. So something like that.
Thank you, Roman. My name is Katerina. In topic modeling part, we were trying to answer the question, does patriotic narrative exist in literature of chosen segments, children's literature? And is it an important topic? Thanks to Rena's research of word frequency, we see that words connected to Ukraine's history and politics, they are really in the center as are family-related terms. We'll see that further. We hypothesized that patriotic education as a form of political education played a really important role in children's literature preserved by Ukrainian diaspora, because these themes were suppressed by Soviets and substituted with communist propaganda in Ukraine at that time. We've used two different approaches to the text topics. First, the topic based on transformers, though being more modern one, did not yield meaningful results. Possibly due to poor training on Ukrainian corpora. But it gave us very interesting insights. The model considered political and historical terms to be too prevalent to contribute to topic definition, and that speaks to our core hypothesis. After we've used second approach and vectorized books with word-to-vec pre-trained model, used k-means to divide vectors into 5 clusters, we could clearly see that one of the clusters shown here focuses on historic and political terms. Terms suggestive, козаки, військо, гетьман, земля, Запорожець, і таке інше. After drilling down into these topics using more finely grained 15 clusters, we see even sub-themes that grow from certain historical themes and relate to more, and some of them relate to more high patriotic sounds. Themes covered mainly Cossacks' valor, confrontation with Poland, Kievan Rus spirit, and poetic patriotism. Irina?
Ira, you are on mute. Sorry. So yeah, my part was to analyze word frequency, and for this type of analysis, we have decided to split the data set by decades. And for the specific part of the research, I had 76 books in 7 decades. And the graph on the left and bottom shows the histogram of the amount of books published by decade. And we can see that the majority of books in our data set were published in between 1940s and 1980s. First, I did a short analysis of the words, lengths of the words in sentences to see if there are any differences specifically for children's literature. And indeed, the children's books had on average shorter words, shorter sentences than literature for, let's say, adults. The graph on the right shows the average length of the words, which was nearly 6.5 to 7 letters per word. The most popular words in children's books were kozaks and knyaz, taken 0.5%, 0.3% respectively. And for bigrams, there were mostly Bogdan Khmelnytsky, Volodymyr Velyky are the characters in these children's books, but also Vійсько Запорізьке, Київська Русь, and some other words that again were related to these topics about Cossack age and Kiev Rus age. Also, you can see on the graphs below that the topics about Cossacks and Knyaz and Kiev Rus actually remained the same over the decades. 1980s, Cossack is the biggest word, 1940s, it's also Cossack, Zaporozhets in 1970s, and so on. So this seems like the most prevalent topics in children's specifically literature. And other frequent topics that followed this historical patriotics topics were national identity and nature. For national identity, it was about Ukrainian people, language, flag, Ukrainian land, and for nature, again, as Roman also mentioned, it was voda, these, some other words. And starting from 1950s, some new words about traveling appear in the data, in the wording set, naming different cities, different countries, currencies, and in the 1980s, truly the technology words like the phone, the technician also appear in the data set. Sandra will speak next.
Thank you, Irina. Yes, and the last part of our analysis was sentiment analysis. So we tried to answer questions. So what are the sentiment approach in children's books? Are they mostly positive, negative? And is this sentiment coloring somehow related to some specific topics, for example, historical periods or occasions? So can you please next slide? Yeah, with analysis of the whole children's book data set, we obtained that most of books have neutral sentiment, so which we can see on the this histogram below. So it's mostly neutral, plus minus 0.2. And the proportion of the book with positive and negative sentiment in the whole children's data set subset is almost the same, so with slightly prevalence of positive books. Then we made analysis of positive books with positive sentiment and books with negative sentiment separately, and had this word clouds. So here we can see that the books with positive sentiment has big word, a lot of words knyaz, and we can assume that it's something related to the Kievan Rus, and the word cloud of books with negative sentiment are more brightly show us that the words like Kozaki, Kozakiv, so we can assume that it's related more to the Cossack times. So we took clusters from Katerina's part of the work and analyzed separately books which refers to Kievan Rus time and separately books which refers to Cossack times. And so we confirmed our assumptions that all of the books which were related to Kievan Rus was with positive sentiment, and all of the books with refers to the Cossack times have negative sentiment. So it's kind of interesting insight which we get from this analysis. So, and yeah, let me sum everything up, which what we did in this research. We had that the topics of children's literature are mostly related to historical and patriotic themes, while the topics of the whole data set are mostly social and family, and the most popular words are Cossack and Knyaz in children's literature, and bigrams, trigrams shows the same. Books about Kievan Rus have mostly positive sentiment, while books about Cossacks have mostly negative sentiment, and we did a classification model that predict more than 2/3 of the data set correctly. Yes, and of course, this research, as any other research, has a large field to improvement. Of course, adding more books should help to train the models better and get better results, better understanding of the insights. Of course, improving OCR also will help because not all books have separate words and data which was good for analysis. And since dataset is limited to only one source, the further inclusion of more sources and also books which were published in the Soviet Ukraine in the same time period will contribute a lot to the analysis. For example, it may give useful insights into the differences in the ideological approaches in children's literature. Also, it would be very interesting to analyze with more books and with more themes, sentiments of the book, so we can get some insight and some relations between the epoch themes, the book types, and so on. So here it is. It was group novels, literature, and poems, and we thank you all for your attention.
Thank you to the group NLP. Let's give the group a virtual round of applause, either in the chat or as a reaction. So let's.
Thank you so much.
It's really much appreciated. Any questions from the audience? Okay, let me start with the kickoff question. And after that, of course, if you have questions, feel free to speak up. So for the classification algorithm that you use, you pretty much assume that the book can only belong to one class, yes? If I understand correctly.
So frankly speaking, I've tried different approaches, including I have used original labels. And if you use original labels as a classifiers, in your samples, some of the samples would be just one book, which is not kind of nice. So, and it wouldn't probably produce very good results. But despite this fact, the difference between using original classifiers labels from Tula and using a slightly transformed version, it yielded almost, I would say, similar results. The difference was just a few percent.
Yeah, but did you try the multi-class classification? So when, I mean, not the multi-class classification, did you try to classify when the book can belong to more than one class? Because it looks like in this confusion matrix that you showed, and yeah, let's probably go to that slide. It looks like the assumption is that a book can only belong to one class.
With this model, it's true. But as I have already said, I've tried another approach when the book was could belong to more than one class, and the result was worse. So I decided to stick with this.
I
model.
See. So what was the accuracy in that case, approximately?
It was around 5% less.
Okay, I see.
I have tried some other algorithms like grid search, but the model didn't produce results at all because I got errors that too few samples to do the training and testing.
Yeah. Okay, makes sense. Thank you. Any other questions from anyone? Please, if you see something that is interesting for you, don't be shy.
Yeah. So I also have a question regarding classes and regarding your training sample. Did you consider the books with several labels in this training, or you just skip them?
Could you please rephrase the question? I'm not sure okay. I understood it correctly.
How did you consider the books with several labels, with several tags in your training?
Okay, so we are back to question number one. I have used the first label with an assumption that is stated in my report, that the first label is the main label that classifies the book. And that was used in the final model. And what you see the output of that model, the plot. Have I answered your question?
Yes, yes, thank you.
Okay, any other questions from anyone?
Please fire away.
In that case, I will have a second question.
I also would
like to ask. Ruslan, please.
Actually, this slide is very interesting, and I see like accuracy 32%. And what do you think, whether it's good accuracy or bad accuracy?
Okay, so it depends on the business goal. Some business would be glad to have at least some prediction, and other businesses could ask for a super precise prediction. So obviously, 32% is not good enough to fire all your librarians who manually classify the books, but 69% is something that we can work towards improving. And as my colleague said, we know the ways how you can improve this score. Just for your information, there are a lot of classification that have less than 5 samples. And it's difficult to train the model to predict something among those 5 samples.
Yeah, so another question could be whether you tried any other metrics, because like accuracy is not very representative metric. Assume you have like 90% points in your data set labeled as class A and 10% as class B. That is very similar to what you described. It means your data set is highly unbalanced. So when you kind of classify all points as B, that is most represented class in your data set, then you got like very high accuracy. But your actually predictions may be very poor. So have you considered any other metrics?
In the report, I have also used some other metric like F1 score, and I cannot recall from top of my head what was the F1 score, but I decided to show the accuracy as a score, and F1 I can provide you upon your request after this meeting.
Okay, thank you.
Yeah, that's actually, in my opinion, their accuracy is pretty good for the multi-class classification. Yeah, if it was a binary classification, it's just 2 classes, definitely that would not be good. But if you think about, you have probably around 15 classes, or let's say 10 classes in this data set. So if you naively randomly assign a class, the accuracy would be just 10%, these 10 classes. So here, yeah, probably up to, yeah.
21. Right now we are seeing 21 classes.
Okay, so for the 21 class, yeah, the accuracy of 69% is pretty good, and the accuracy score is also a good metric. Unlike it's for the binary classification, it's different. And yeah, 69%. So let's just think logically. If you naively assign 1 class randomly out of the 21 to each book, so your accuracy would be around 5%. So that's what you can do naively. So and yeah, 5 with a naive random assignment, and 69 with the SDG algorithm is really good.
Yeah, maybe one short comment regarding so sometimes it's good to have some baseline. As Alexander said, you could use like random guess as a baseline, and then show that, for example, the naive bias improves a baseline, and then SGD improves it even more.
Yeah. Thank you. Thank you to Group NLP, unless there are any other questions from anybody. Going once, going twice, done. Thank you again to the group. Let's give the group the virtual round of applause again, and let's move to the second group, which is Red Eyes. Please.
Hello, everyone. We are Red Eyes team. At the end of the semester, the name of the group is even more reasonable. There are 4 of us, Taras, Roman, Evgeny, and I will start from the books classification. As any other teams, we worked with Electronic Library of the Toronto Ukrainian Library Association, in short TULA, and most of the books are collected by the third wave of immigrants from Ukraine in the period after World War II. And Ukrainians were forced to live in search of freedom, opportunity, and better life. And we know that during this period, Ukraine was under Soviet power, where there was no freedom of speech, where books were censored, literature that negatively influenced the communist comrade in the authority opinion was banned. And it doesn't matter whether the migration was forced or planned, people took the essential with them: documents, money, jewelry, necessary clothing, and books. And not each books. It's were only most important and valuable of them, which probably inspired, support, told the truth, and needed to be preserved. And the good question is, what do books say about Ukrainian immigrants? And if we display the most used words in books, we get the following word cloud. And we could see that these books raised ideas of violence and suffering, the division into my people, I, and others, like Odin, Nash, Inshi, an analysis of the times, what's happening now, and what's to come, and motherland and language. And this idea are essential for human development, especially in a difficult time. And if we look closely to the books in Tula, we see that they are special because it's not the most read books or the oldest or newest. It's not the most popular author, not a particular genre. And these are books that tell us what was important and valuable, especially to Ukrainian immigrants. It's the opportunity to understand history through their eyes. And the question is, who is interested in such books, and who is the library readership today or potential readership? And we could focus on 4 groups, 4 target audience. First of them, it's grandson and daughter of third wave immigrants, historians and cultural researchers from both from Ukraine and other countries, and Ukrainians who are reconstructing the lost history and culture of the Soviet period. And on the last one, we focused most. And the good question is where, what, and how do Ukrainians look for information about Ukrainian past? Of course, in libraries, but most often by text on the internet. And our assumption was that actually they don't care whether it is a text, picture, or a book. It doesn't always matter what genre of the book it is or who its author is. That's why we try to build classification not from top down, where we adjust an existing classification of the books, but bottom up, where we create a classification based on books and their content, words in our case. And this experiment may give us some interesting insights, or of course not, we'll see. We built a topic modeling, in that case, let and Readership allocation, which could get us the idea which words are similar to each other and what groups they could form. Shortly, how it's worked. We take all texts in all books, and we form the dictionary, unique lemmatized words, and also we form the corpus, how many times each word appear in along all text, and we set number of topics manually. And in the results, we get topics with words and could, after that, give the interpretation what's this topics about. So in the results, we have 10 topics because we set it before, and we can see that some topics are part of others, so we don't care about them. So let's take the third topic, for example, and see what words it included. And we see that it's words like просокати, притриманий, дирижизм, УНР, Українська Народна Республіка, Республіка проурядової, уціліти, валує, вслідкування. And we could understand that it's they are all about politics or its application. If we take the fourth topic, we could see the words like книговод, консультуватися, видання, ясновидіти, переговорюватися, порадувати, засліпчуючись. These words are about clear vision, knowledge, and some skills. So we could call them name this topic like the path and how to come for the future. And up we have books divided into 6 classes with the following titles, like Escape, People and Their Life, Politics and Its Application, The Path and How to Come to the Future, Avoidance and Acceptance, and Reactions to the Problem. This is my part, and I pass the word to Roman.
Hi, everyone. So my part of this task was about word analysis, which I started with small agenda. Because since we had a pretty significant number of books for different years, we wanted to analyze the evolution of Ukrainian language. For the task, we have analyzed words usage by the years. It may be helpful for the future research of changing of our language and give a picture of the influence of real world events on literature and language, some like a war or tragedy or some poetry. We had about 2.8 million words for this task in range from 1890 to 2010 years with 4 or more letters. I assumed that it's an essential condition to avoid conjunction words and errors in recognition. Next, we take only most popular words that with at least 20 usage in 3 years. So we're left with 49 words for this task. Next we can see distribution, books distribution through the years. We can see that we have a massive disproportion near 50-80 years. And we see that if we analyze each word independently, we see that this proportion stays for almost all the words. Next, we can see that if we analyze each word independently in usage by the years, we can assume that some words, usage of these words was changed. Yeah, for example, Zemля was decreased. Communistic was slightly increased in 40-80 and then goes down. And we can assume that we can make from this book some investigation about this. So results that we received, we have about 15,000 words that have increased, 1,500, excuse me, words that have increased usage in the literature and 13 that have decreased. We made a linear approximation and grouped the results into 2 groups to find which group our word belonged to. And we can see that, for example, we can see Жандарм, Против, Шельменко, Тілько, Відтак, Не будь, and others. It's archaistic words and they have been used less and less, and new words become more popular, like головних Україною державі незабаром інтереси. So we can assume that literature can show us how our language is changing, so we can see some influence of and see some influence, real influence of real world events. So, and I give a word to Taras next.
Hello, everyone. I was working on named entity recognition for on top of these books. And a few words, general words about it. It's about finding persons, locations, organizations, something like Україна, Шевченко, спілка письменників України, what we call власна назва. And I was interested in finding the most important, maybe the most popular and named entities in a specific book, and find books that contain a specific named entity. So we have a data set of almost 3,000 books. There were like more than 3 million named entities found. On average, there were like more than 1,000 named entities in a book, not unique. And on average, the 10% of the known words, the words that were found in the known vocabulary of the known words, were named entities. For this task, I used for creating a vocabulary Dict UK project from Lang UK, Ukrainian group that work on NLP tasks. And also they contributed a named entity recognition model into Stanza library, that is a common library for NLP. And I used that library to find named entities. The input to the pipeline were lemmatized texts. Lemmas were created also with the help of Lang UK repositories. So we have a service, an API with 2 endpoints. The first one searches for named entities, the most popular named entities in a particular book. All named entities were pre-computed and stored in SQL database. It's all deployed into Google Cloud. They were pre-computed and stored in database, and Flask service is just searches for a particular book and returns the most popular based on the count here. Here, count metric may not be the ideal. So later I did some research with a TF-IDF metric that may find like the most relevant and not just popular named entities for the book. Yes. Also, for this endpoint, we see there is an optional flag entity type. Entities can be of different type. It can be a person, a location, an organization. So we can find for most popular locations or person in the book, in a specific book. Yes. Could you go next? Yes, the second endpoint, it searches for the books that contain this entity, and also it returns the most like popular, the books where this entity was found the most. I was thinking that the possible improvements for this API could be also returning the page number, the exact page where this entity can be found. It may help researchers or someone who wants to read immediately about someone, about something. Yes. And this was just an experiment to not just to take into account how many times, but also inverse document frequency. Multiplying the frequency by inverse document frequency, it tells something about the relevance of this named entity in this specific book. because something that happens in all of the books is not that relevant for a specific book. And if it happens, if you can find it only in this book, then it should be relevant here for this book. So, and on this table, we can see a comparison of entity count and entity TF EDF, and they were slightly, the order was slightly changed because of it, because of the account of inverse document frequency. And we can find that in this book, «Ой, не ходи Грицю та на вечорниці», the most popular is Darina and Potap, based on entity TF EDF. The conclusions were that some of the entities were split into multiple and they can be grouped in order to improve the solution. Like here we see Vasil Simonenko and Vasil Simonenko. It's clear that it's all about the same person. And also the possible applications of it, as I've said, it's like finding books that contain a specific innate entity and show all the books that where this name entity can be found. It can be used like for adding text maybe to the book on a website. Yes. And I give the word to Evgeny.
Thanks. So, ladies and gentlemen, I would like to present the problem I was trying to solve, and finally I've handled it. Yes, thanks. So I've chosen the problem like to have ability to see the related books. So it's a book recommendation, and as you know, this system helps readers to see related books just during reading the description of one of the books in Tula online library. And as you know, we have two types of recommendation system: collaboration. Please go to the next slide. Yes, as I said before, the problem is ability to see related books. Go ahead, yes. And as I said, we have two types of recommendation system, as collaborative filtering and content-based filtering. My choice was to take content-based filtering type because we don't have enough data about users' preferences. So the user goes to the Tula website, choose the book, what is interested to him, and additionally, he can see 5 related books to his book choice. Yes, and go back, please. And yes, as a business-oriented presentation, business will always wants to understand what they will receive after implementation this feature into production. So my hypothesis is to increase readers' attention to the website. And as a result, I believe this feature helps to increase it, and of course, readers have ability to see the books which are related to his preference. And now you can see the result of the system on this slide. That's done for me. Thanks for your attention.
Thank you. It's all from us.
Thank you to the group Red Eyes. Let's give the group the round of applause. Great results. So any questions for the group? And I can start probably. So I have one suggestion. So Natalia, it would be very useful to see the representative books in a couple of topics that you identified, just to show the titles or the covers of the books in these topics that you identify. It would be very, very illustrative. That's maybe something that you can do for the Tula competition. And yeah, a question about the named entity recognition. So there are two entities that looked really strange, Wand and Choma. So what those mean? If you go back to that slide with the named entities, Ukraina, number 1, and the second was Wand, and I think number 6 was Choma or Homa. So what are those? And yeah, feel free to go back to that slide in the presentation.
Do you see my presentation?
Yes, but it's the last page. Yeah, this one. Yeah, second one and number 5 Choma. So what those mean? What those named entities mean?
Actually, I did not find did not have time to look for one in the books, but it was very interesting to me because it was very popular. For Choma, I looked and I found that it was a village in Carpathian Mountains, but didn't find why it's so popular. Actually, nothing else than a village in the Carpathians I didn't find.
Interesting. So would be curious to know what is Wand.
Yeah,
if you find out, please post on Slack.
I will do more research, yeah, because it's one of the most interesting, I think, in this.
Yeah. Other questions for the group, please?
I have a question. Thank you for your presentation. It was really great. And maybe not question, but suggestion, it would be cool to combine your named entity recognition with your word analyzer and see when for example, Choma is fly to the moon and so on. Yes.
Yeah, you see, while I'm doing my task, while I was doing my task, I found that almost all name entities that I've look, they have significant spikes in some books. So I didn't make a slide with this, but on these plots, we can see that in some years we have significant amount of some name entity. I guess I post later it's in Slack, so you can see it.
Okay, if there are no other questions, thank you again to the group Red Eyes. And let's move to the presentation of the group Axolotis. Yeah, Natalia, if you can stop sharing the screen. Yeah, now the group Axolotis can share. Thank you.
I don't think we can hear anyone.
We don't hear anyone.
But we can see the slides.
Yeah, sorry. Probably I was muted all the way. So good afternoon, if you didn't hear that. And we're Team Axolotls, and I would like to present our project on automated text and book cover generation. So while looking for a project idea, we kind of took inspiration from these three questions, which pushed us to work on this effort. And so, while the first question you see, does the world need arts, is probably rhetorical. The second and third, so is it necessary for an artist to be a human, and can an aesthetic work of non-human be considered art, are something that may be explored and answered in very many different ways. So this question in one or another form is quite old, and in the classic Greek thought, for example, like simplified by Plato here, art is meant to mimic the reality. And so this point of view has remained intact for many centuries, but right now we're living in a post-meta something modern world, and the common views on what may or may not be considered art are much more liberal, so to say. And for instance, there's a whole field or genre of generative art where works are produced by AI. And this is what we essentially aimed for. We wanted to understand if state-of-the-art artificial intelligence tools could provide genuine, could produce genuine like works of art that can be, in the very least, enjoyed by humans in some way, and at best resemble a work of a real artist or an artist. To start with, we collected the text corpora and from the tool library and tried to clean it. But this is important, probably important remarks that we found it still too too noisy to work on, and so we ultimately downloaded 10,000 books from another site. So yeah, this is kind of where our texts come from. And so here I shall pass the word to Andrei Statnik, who worked on the text generation part.
Good afternoon. I assume you can hear me. Right, so first of all, I'd like to also add a little bit on that. First of all, we nevertheless used the Tula dataset, and you will see usage later. And also, I believe that others took a good use of the dataset which we shared, and we already saw a lot of cool applications. I'd like to start with the text generation. And of course, researchers have asked the questions we asked a couple of times ago. For example, I read an article which is called "Can AI Write Like Shakespeare?" And right here on this slide, you can see at the bottom left corner the quote from the Othello, and the italic part was written by Shakespeare, but the continuation was written by recursive neural networks, which example architecture you can see on the right hand side. But first of all, since that article was written, natural language processing took big and many steps forward, and nowadays the state-of-the-art algorithms perform much better. And second part, which is more important in my opinion, is that those approaches, those models, they usually have to be recreated for each language separately. And well, it's intuitive that a lot of research was done for English and German, probably a couple of other languages, but for Ukrainian, the field is still pretty empty. And we wanted to ask like similar questions that our colleagues, researchers asked a couple of years ago in English, but with modern approaches and for Ukrainian language. Before we get to the technical details, I'd like to pass the word to the Pawlo Tyszewski, who will tell you about the next part of our research.
Yeah, hi everyone. So the image generation was another part of our project. Basically wanted to create book covers. And probably as all of you know, it's like a very developed field already with a couple of years of flourishing. It all probably started with the adversarial networks, and now it's more contrived with the transformers and CNNs. So we will also delve into details later. So next slide, please.
Right, so to start off, I'd like to describe our approach to the text generation. As a model, we took the best available trained model in Ukrainian because we didn't have capacity to train the model from the scratch, and it happened to be GPT-2 with 124 million parameters. GPT are modern state-of-the-art approaches for the text generation, and currently it's one of the best widely available models, even in English. Recently, a new version appeared, but it happened to be so powerful that the authors decided to keep it proprietary and distribute only as an API. Actually, this part of the research was a continuation of my diploma project in the bachelor. While I was pursuing bachelor degree, I was researching different methods for Ukrainian text generation, and surely this model showed the best results. For this task, we used transfer learning. We took a base trained model, which was trained on more than 4,000 fiction books. And after that, we used transfer learning to first create 4 models for 4 different genres. And after that, we trained each model separately on different authors, some of which you can see on the slide. And as a result, we had 24 models for each combination of genre and author. The results you will see a bit later, but I'd like to say that I personally was pretty content and surprised. Even one of the most common problem with such models, which is extremely often appearing text repetition, was reduced as far as we could by tuning temperature and trying to use more books. And eventually it looks more or less like a human, text written by human. And in fact, on the next slide, if you could kindly change, you can see the sample. I suggest not reading it aloud, just wait for 10 seconds. People can read it in silence first. Again, it's text written by the model which was trained on the Ivan Franko's books, and it seems to me like horror or probably fiction. And later you will be able to take a look at some books if you'd like to, and you can compare texts and see by yourself whether they resemble the authors. I guess we can go on, and I once again pass the word to the Pavlo to continue.
Yes, so for coverage generation, we use the generative adversarial network. And this is like the simplest possible description of its architecture. Can you switch to the next slide, please? Okay, and this is the examples of the covers that were generated. So we used the WikiGAN model, which is pretty advanced. It was pre-trained on the different art images. And what it was also capable of is to generate image only from text. So to make it author specific, we took like the most interesting words for the specific author, let's say for Shevchenko. And then we took an extra couple of words from a genre to make it genre specific and combined it to seed this generation process. Next slide, please. We don't hear him.
Evgen, we don't hear you.
Right here.
Sorry, yeah. I thought Pablo wasn't done, so I should shortly add that yeah, we indeed used the Tila data set for the generation of covers. Yeah, that's another important remark. Although texts come from a different source, and so at that point when the covers and texts were generated, we had images and walls of text. Kind of many documents with just walls of text on our hands. And we wanted to glue them together in a way that would give a user a genuine book reading experience. So we generated titles from other randomly picked book titles, to give a hint of what a reader might expect to see inside. Then slice the text into chapters, also based on random or other pseudo-random lengths, and pack this into PDFs laid out like real books, so you can see a sample here. And you can download a few examples to see for yourself and decide if all of this may be considered real art. Though our opinion is that at this stage, these books still, well, largely make an uncanny impression. It is still kind of impressive what the modern algorithms are capable of, and ultimately, this is still art, and we kind of put our souls in it through a medium of artificial intelligence. And with the years, it will be increasingly harder to distinguish an AI-generated book from one written by a real human. So this concludes our presentation. Thank you.
The group Akilotis, let's go give the group the virtual round of applause for showing us the future of the art. So any questions for the group?
Yeah, one question. According to image generation, you said that you used WikiGAN. Was it like just generating with WikiGAN, or was it some combination with other models? Because like it needs some kind of metrics for generating. And what did you use it for? What did you use for these metrics?
Again, Paulo, we can hear you.
Sorry. Pavlov was responsible for generating the covers.
Okay.
So we can't reach him or can hear him. Not sure why.
Right. I suggest to move to other questions, and while we will do that, I'll think Pavlo. I guess he might have internet issues or something, and at least try to ask him to go back or write down the answer if he can.
Yeah, sorry, I missed it out. Do you want to repeat the question?
Yeah. So you said that you used VQGAN for image generation. Was it just VQGAN, or was it combined with some other model, some other techniques?
Yeah, it was combined with Clip, and I don't really remember what it was.
Okay, I see. I use the same approach. This was the reason I was interested. Yeah, thanks.
Yeah, I think we use the same project model probably. It's actually kind of tricky to find the working model. I tried like 3 different versions, and only one of them was working, was like functional.
Yeah, thanks.
Any other questions?
Yeah, I have a question.
Yes,
maybe regarding the length of the books. Can you elaborate a little bit about those lengths? I saw it was like around 30 pages. Is it good, or is it too large books for GPT-2, for example?
Right. So the point is that the book, the text generation it's certainly, at least I couldn't make it create such long texts. So I had to come up with the hack. I managed the model itself to generate 1024 symbols. And I came up with the trick that first of all, I took a random start. I just prepared a couple of sentences like he was there for the first time, Natalia got up early or something, and then asked the model to continue on that part of the text for like slightly above 1,000 symbols. And after that, I took part of the generated text I came up with 300 symbols, but it is a hyperparameter. And after that, I feed those symbols back to the model to generate once again what is left, 700 symbols, and the process repeats itself. Right. The point is that using this approach, the model tends to stuck in the loop. So a lot of effort was taken to avoid that because it might randomly generate all the text of the word of some word, I don't know, like kartopля, and then I will feed kartopля back to the model again, and it will generate the same text, etc., etc. Did I answer your question?
Yeah, partly. I also wanted to know, isn't 30 pages too much for the meaningful text?
Okay, so usually when it doesn't come up to what I described with the repetition of the words, model generates pretty good text in terms of the sense inside sentences, or like the close sentences are connected, but the overall plot, it can use only the information from those 300 symbols to understand what happened before. So it doesn't have like very long-term memory.
Thank you.
You're welcome.
Okay, any other questions? Okay, so I have a very short philosophical question, of course, about the text generation. So do you think in the nearest future, you would be able to, or the researchers would be able to generate meaningful, complete texts of at least, I don't know, 10 to and more pages that have basically have an idea, that have the beginning, that have the end, and that resonate in these people?
Right, that's a good question. And in fact, while I was doing the diploma project, I compared n-grams and recursive neural networks and the GPT-2 approach, and those came like more or less 20 years apart, or 10, I would say, and the difference was drastic. And recursive neural networks, the simplest ones, they barely could learn the language and come up with more or less little bit connected words together. But while GPT-2 could create sentences which have sense inside them, but also this closed sentences are connected. And right now, as we can see what's going on with GPT-3, people made it prove theorems or write code or obviously create texts. So it's right now not even about text generation, but it could do everything which could be expressed in words, which is basically everything, I guess. And as I personally understood that eventually it comes down to the amount of the data and the amount of the parameters and time of the training. As in my understanding, they did not come up with like crazy, super mega smart ideas, game changing in the newest papers. They basically crank up the amount of parameters and data. Surely they do their research, but that's the most part, and I don't see any problems for them to continue. And in fact, I guess the new model comes every 2-3 years. So I guess in 5-10 years, it will be much, much better.
Yeah, great, thank you. So let's give the group the virtual round of applause one more time. Great glimpse into the future, what lies in front of us. And let's move to the presentation of the Infinity Flex team, please.
Hello, please say if you can see my screen.
Yes.
Okay, great. So I'm starting a presentation for works of Infinity Flex team. And the main goal of our project was to improve user experience for existing users of Tula site. In order to do this, we started with use case analysis and identified two main user groups. First user group is a general user, a person just interested in Ukraine or Ukrainian language. And the second user group is specialists, like history, linguists, sociologists. And for the in the scope of this project, we've chosen a general user. Some examples. Our first model was Marichka. She's 19 years old and she studies applied mathematics. And she would like to get a general understanding about Ukrainian immigration and how can we help her. First of all, we decided to generate a short book description and do some kind of visualizations. Our second user we had in mind is Vasil. He is 40 years old, lives in Canada. He is an electrical engineer and he studies Ukrainian. He has read some of the books already, and now he would like to find books similar to one he liked before. So to help him, we could build a recommendation system. And their second useful tool would be a book filter, because he may know what he liked and he would just sort books and show the most interesting. And here we could create a category filter. And based on this, we created a task list for our team. First is a book optical character recognition, because a lot of algorithms here needed a full book text, and this is a central task for us. The second task is automatic category classification, and it would help with the filter for Vasil. The third task is book summarization. It would help create a quick presentation of a book, and recommendation engine. And first task, I will give a word to Konstantin.
Thank you, Julia. So my task was to create an algorithm for extracting texts from books. Next slide, please. So the goal is to create a text version of scanned books without the text layer on it. The requirements was scanned files, as it mentioned, and there is one little restriction. Output texts must have a minimal post-processing because some of my teammates need a full texts without stemming and demonization for those algorithms. So yeah, next slide. Here you can see a pipeline, how it works. So at the beginning, we have a scanned book version. After it, I split all the pages into separate images. And then I perform a little pre-processing to every image. It's kind of grayscale, sharpness, and angle correction. Then for every page, I have run a Tesseract algorithm with Ukrainian and English extractors. After all, I need to join in right way those chunks and give an output as an TXT file to my colleagues. Next slide, please. So here you can see pre-processing results for some image. As you can see, it was rotated on the left, and after pre-processing, we see that sharpness little increased and angle was corrected. So yeah, next slide. Sorry, did you hear me? Maybe I have internet issues.
I can hear you. Next, one more next.
Yeah, we hear.
Yeah, no problem.
Kostya?
Disappeared.
I'm sorry, I got an internet some fail.
Instruction.
So,
yeah.
Yeah. Here you can see a complete result after all preparation. So on the left side of slide, you can see an image of a book. On the right corner, you can see a text, how it's recognized. For every book, I spent around 2 weeks to process all the data set, but it's a lot of data. So yeah. Next slide. So.
Yeah, so our next task is category classification. And the main goal for this task was to classify a book by a category, and requirement is labeled data. So this is as far as this is a classification algorithm, it requires data. So the main business value is about user experience, but it also will give will save some money by reducing categorization cost and given the speed. And I started with data set analysis, and I used data in tag like prose, history, poetry, and full book text. Other data was not useful for my part of an algorithm. And here is a distribution of categories that had that had sufficient amount of books. And I've chosen for the purpose of this feature, I've chosen only books with one tag to make easier training and classification. And as you can see here, the prose tag has the most books in it, and as a simple baseline here would be a classifier that would predict around 23% of accuracy. My pipeline consists took a full book text generated by Konstantin, then I did a cleaning, lowercasing, tokenization, systematization. After that, I created word vectorizer. It takes 500 most frequent words in trade text. And after that, I converted every book to this vectorized view and trained two linear classifiers, native bias and spam. As the best result has SVM classifier. It gained overall accuracy of 73%. Naive bias was worse, like around 50% of accuracy. But like for this single class classification, we can see that some classes were misclassified, were like, for example, children's literature were misclassified as prose, which like it cannot be told that is not true because it's a prose, but like this classifier was single labels, and this is a result of what we get. And in average, for most of the books, the classification is quite good. And this classifier can be used as a good baseline for a further algorithm improvement. Some examples of correctly classified examples, and here you can see the most frequent keywords from a feature vector, examples from incorrectly classified examples, and if we just examine them, so sometimes we could see some words that are not correct, and this is because there are some errors in OCR and not enough preprocessed and added. And as a further work suggestion here, I would propose to improve data cleaning, think about categories, and the most important two are add more categories, as it will improve user experience greatly, because here we had only like 11 categories that I trained my classifier on, but we could extend these categories by more wide variety, but for this approach, the external data is required. Also, it would be useful to train a multi-label classifier because naturally every book belongs to several labels. That's it from my part. Dmitro?
So my task of the work was the automatic book summarization. And next slide, please. And the idea was to generate a really short representation of every book in the dataset, and in different ways. So I chose 3 ways. The first way is generating a graphical representation word cloud. The second is taking the most representative sentences in the book, which is called the extractive approach. And then the third approach was that generating a new text based on the extractive summary, which is called the abstractive summary. I processed almost 40% of the books in the dataset, and it was quite quick. The next slide, please. So the first part was to generate a word cloud for every book in the dataset, and it was based on the word frequency in the particular book. And here you can see some fancy results from the processed books. And some of the words are excluded, like prepositions. The next slide, please. The next part of the work was to generate an extractive summary for every book that may be used in some, it can be used, for example, for the end user, for a library site visitor. We can show him a short representation of the book with it will be the automatic representation with some manual corrections, or it can be used for a representation for the next algorithms. There was used a statistical approach that I compared distributions of the tokens in the whole book and in the summary, and the summary is statistically more similar, the most similar to the whole book. And the next slide, please. And the last topic was to generate an abstractive summary. And here I used a pre-trained model, multilingual Excel sum. It was trained on the BBC articles, in particular in Ukrainian language. And here I had some strange and different results. Mostly they are good, but they need some corrections. For example, here it is a good summary, a little bit worse summary, in which we need to remove some sentence some redundant sentences. And sometimes it gives something like funny results, like the last result. And the main issue might be that I worked with Ukrainian language, and so there are no too much models for summarization. So the main purpose is to use a better model for abstractive summarization. The next slide, please.
Yep, so this is my part of work. Hello, everyone. And I'd like to present a recommendation engine to suggest similar books that I've built in my part of this task. So next slide, please. Yeah, the idea of my recommendation system is to use word embeddings, which are numerical and dimensional representation of a word, in order to build content-based recommendation system. In order to process less data and to use only the most representative sentences of the books, I used text summaries generated by Dmitrov. So my pipeline was, I took the summary, I cleaned the data, lowercase it, took word embeddings, and found most similar books comparing average word embeddings. I used Ukrainian word embeddings model trained on large-scale data, and I checked that the most of words in the summaries are present in the dictionary of that Ukrainian word embeddings model, and I got the result like 90%, which means that this model is suitable for us. So next slide, please. I got the results which can be seen on the picture. So, for example, for the book Samostina Ukraina, it recommends Moskovsky Sphinx, and for book Свідок спогади про голод 33-го, it recommends Чужиною спомини. All in all, the results were pretty accurate. And next slide, please. To test the recommendation engine and to visualize the results, I used dimension reduction algorithm to visualize all the books that I've processed on a two-dimensional plane. And I understood that I saw that the books were divided into three clusters, three clusters of books, and the top cluster contained sad, mostly sentimental bunch of books. The left bottom group consisted of fiction books, and right bottom group consisted of mostly historical ones. Of course, they are not all the same in the cluster, but as we can see some connection. And my engine can be used for improving the user experience of the user of the website, Tula website, and that's it. Basically, thanks all for the attention, and that's all from our team.
So thank you to the group Infinity Flex. Any questions for the group? Let's give the group, of course, the virtual round of applause. Thank you so much for a very interesting presentation. While you think about questions, I have a couple of probably more suggestions than questions. So yeah, for these clusters that you are showing, it would be nice to first, to overlay the cluster names. This image that you are showing on the screen, and to potentially show a couple of representative books from each cluster. The same for the word clouds that you displayed. It would be nice to show the books that those word clouds are for, maybe the covers of those books together, so that we can relate those to the word clouds. But again, this is something that you can probably think about for the Tula competition, just to make it more visual, because that audience will be much more general audience than we are. And of course, will be much less savvy in the AI field and in the field of the algorithms. But yeah, those are just comments from me. So questions, Alexei?
Yeah, hi. Thank you so much for your presentation. My question regarding this summary generation. So first of all, the last one you mentioned, the worst one, those examples, it looks really interesting. I mean, like some summary of alternative history fiction book when Karl Marx is German Chancellor. My question here is that what kind of tools did you use to generate those summaries?
Thank you for your question. So for this type of summary, for abstractive summary, it was based on the extractive summary. So I took the most representative sentences with statistical approach, and then I used a neural network, a pre-trained model, which is called multilingual Excel sum. So it was trained on BBC articles for approximately 1 million BBC articles for 40 different languages, including Ukrainian. So it was generating the headers for the articles. And it seemed that it can generate the short 1 or 2 sentences representation for the book based on the other short representation of the book. So this was my approach for generating this summary.
So you mean that so the input for the neural network was a set of most represented sentences.
Yes, yes.
And
the extractive summary.
And the output, those one sentence as we see it on the slide.
Yeah,
right?
It's like generating based on these sentences, but it's fully new sentences with some external lexics which are not presented in the summary. Extractive summary.
Yeah, I see. It's really interesting. And did you do any post-processing of the sentences because they look really correct?
No. It's a raw sentences. For example, if you see on the first, you will see that Volodymyr Vinnichenko одна знайоміше.
Yeah, I see.
It's
okay. So some minor mistakes are present. Okay, I see.
Yeah.
So can you please share with me this library you mentioned, this model you mentioned?
Yes, I can. I mentioned it in my report, and also I can.
Yeah, just put it on the chat. I will appreciate.
Okay.
Yeah, thank you. No more questions from my side.
Yeah, I have one question. Oh, okay. Yeah, Andrei was raising his hand.
Yeah, Andrei, please. Yeah.
Thank you. I have actually a few questions to Yulia and to Kostya. I'll start with Kostya because he was the first. How many OCR of books you have created? Have you applied any measures to assess how good is the quality of your OCR? And another question that supports the previous question, have you compared your OCR engine with some of the existing open source engines?
Okay, so let me answer. The first part of question was how many books I processed. I processed the whole data set that we have, 2005. I don't remember exactly count of book, but it was processed every book in data set. But some books for some reason failed processing. I don't know why, but it's not a big number of it, but around 15 or something like that was processed failed. And there is some books like in album orientation, when you see 2 pages, those not pre-processed because it's pre-processed, it's processed, but the quality of this text, it's very bad because because my algorithm cannot kind of understand that there is 2 pages on one image. And
so have you applied any measures, how to assess, like automatic measures?
No,
this page was
there is no measures.
And have you compared it, your result with a result of some open source?
It's already used open source libraries that already have an OCR mechanism in it. So it's the most popular one. I think it's called Tesseract and Tesseract OCR. So yeah, I'm not sure that I would compare it with, I don't know, BERT Tesseract or something like that, because I had only pre-processing and correcting image and extracting PDF and something like that, all these tasks. All OCR information was extracted using Tesseract.
Thank you. No questions for Yulia. How many books participated in classification exercise? And the second question, how many unique classes participated in your classification? Thank you.
So regarding the books, I cannot tell you right now because I need to look at numbers. But in total, I tried with 17 classes and 11 classes, and in both cases I give was a similar accuracy. Of course, for some classes, I looked at scores like F1 score, precision recall, and for children's literature, I remember some other classes, it was really bad, like with Europe's, but understandable why.
So did you have any criteria of what classes to drop and do not use those samples for classification modeling, or?
Yeah, so I took the classes that has most books in it and dropped the rest. And also I forgot to say all the books were Ukrainian language here. And another criteria for choosing these 11 classes was to have in test set more than 10 books. And test set is 30% of all books. So,
understood, thank you.
Yeah, I had one more question. According to the text summarization, does it have some kind of maximum text input limitations and any limitations on text output limitations, like minimum size of text output limitation?
Okay, for Extractive Summary, I took 20, the most representative sentences. Yeah, and for the model for Abstractive Summarization, there's almost a standard input length, because I took 20 sentences for every book, so it took the 20 sentences from the book, the most representative sentences. And the output was about, as I mentioned before, 1 or 2 sentences. It has the minimum threshold, but it's something about 20 symbols.
What was the algorithm of selecting most
representative sentences?
Representative sentences, yeah.
Mm-hmm. Okay, so it is called KL sum algorithm. It uses the KL divergence. It is the measure of statistical of similarity of statistical distributions. So the book has a distribution of the words in it, and the summary has a statistical distributions of the words in it. And my approach was to extract the most similar to the book in statistical measure sentences.
Okay, I see, thanks.
Okay, thank you to the group Infinity Flex again. Let's give you the virtual round of applause. Great presentation, great discussions afterwards. And let's move to the next group, Dead Poets Society, please.
Hello. Can you see my slides now?
Yes.
Great, so I will start. My name is Evgen. I'm presenting the project of Dead Poets Society team. Here is our team. It's me, Rodion, Alona, and Oleg. We decided to concentrate our efforts not on the analytics, but on delivering the product
based on deep learning that will be beneficial for the customers of electronic library and for the maintainers of library. So here is our product, consisting from 4 principal parts. It's a book digitization, it's recommendation system, category classification, and book description. So let's start. In good old times, people were reading hard copies of books, but nowadays they prefer electronic devices. So for the best user experience, we need to give people the opportunity to read books from phones, electronic books, computers, maybe smartwatches or fitness bracelets, I don't know. So we need the books to be customizable. And that's actually the issue, because from hard copy, we could easily convert a book into a scanned book, but there are 2 drawbacks. First, such version of books are memory consuming. They're quite hard in terms of memory because it's just a collection of photos, and also they're not customizable. One could not change the text size, the text font, the color of page, and so on. And there is another option, using text files that could be converted into text, FB2, EPUB, or any other format and used in any device. Also, it's flexible, it's convenient, it's much more lightweighted, and it's interactive in the meaning that one could use search for some keywords in the documents, or highlight something, or for example, write some comment or some bookmark and so on. So the question is how to move from the left option to the right one. And there is no rocket science in it. It's just OCR, optical character recognition, using of computer vision to recognize letters and to combine them into text. There are a lot of production-ready open source libraries for that. For example, PyTesseract that was mentioned before, but there is a huge problem. There are errors that occur throughout the recognition process. And it's really annoying to read a book with errors. It really mitigates the enjoyment of reading book. And in this part of our project, we propose a solution to this, a post-OCR error correction that will get rid of these annoying errors. So let's see how it works on the example. Here we have a sentence. Сидів він якось з таким настроєм у себе вдома і читав книжку одного молодого письменника. As you can see, there is some problems with this sentence. So the first step is to identify these errors by comparing the tokenized version of the sentence with our Ukrainian vocabulary. After we found the errors, we need to propose some alternatives, how to fix them. And for that, we could use kind of spell checker that propose alternatives based on word similarity. At this stage, we don't know about what word is appropriate because we are not using the semantic meaning of them. We are just using the Levenshtein distance to find the most similar, because usually these mistakes are not in the general word, but in a few letters. And the next stage is our secret ingredient, is using the BERT model for utilizing the semantic meaning of each word, comparing it with the context of a sentence, and finding the best option out of the proposed that will fit the best in the context of the sentence. We are using some Ukrainian version of Roberta, which is based on BERT architecture. And in the end, we get our corrected sentence, which is much more enjoyable to read. So there are 2 principal cases how we could use our product. The first one is fully automatic book digitization. We have a lot of PDFs, and we could implement a pipeline of OCR and our error correction and just convert all PDFs automatically. The downside of this approach is that a certain % of error is inevitable, and there still could be some problems for the user experience. But this approach could be really beneficial for employments of some ML algorithms on the text, because we need to have a text to deploy NLP pipelines, and it's better to have text with lesser amount of errors. And the second option is a smart digitization assistant, which could help to prepare books into the format that will be good for the consumers. and it would be deployed into friendly user interface for the annotator, and a worker of electronic library will just read the book and probably enjoy it, and just look for the highlighted words and for the proposed versions of what will fit the best. So with this approach, we could speed up significantly the manual process of book digitization and to help the annotator to find the best fit very quickly. So let's move to the next part. Recommendation system is actually a great idea that boosted a lot of businesses like Amazon, Netflix, and other electronic businesses, because every person has its own preferences, and in order to make them spend more time on website, read more, or buy more, we need to propose our customer things that will be relevant for him. And so we are implementing a recommendation system. We are using some found of hidden patterns using the meta information of our books, like year, text, description, author, publisher, and so on, and also some internal information, the semantic meaning, by using some NLP pipelines. So we have two possibilities to find the best, the closest book to the one that person is currently reading by comparing the feature vectors of the books. And also we developed a clustering approach in order to customers the customers could read, like to search through the lists of books that are close to the one that he likes. And yeah, so in this way, people could spend more time on electronic library, because the books they will be proposed, they will like them more, and that's actually beneficial for the business and for the user experience. Here you could see the example. One customer read «За державність», Україна під час Другої світової війни, Та людина і вояк, and our algorithm assumes that he will really like Vina Roman by Ludko Feder, which is pretty reasonable, because probably this person really likes books about some war conflicts, because like from different epochs about some conflicts. And yeah, there is also a way to upgrade this pipeline, for example, by collecting preferences and rates, and by proposing books that are not only relevant, but also great and were rated highly by other users. And also, yeah, we could increase size of library and use some custom preferences and users profiles. The next part is category classification. It's crucial also for the navigation, for the management of the library. And sometimes it's difficult to do manual book tagging, because there is a vast amount of book, and like there is no person that could read all of them. So we propose an automatic category classification based on neural network. We are using also all the meta information available and some internal information. And here you could see the results. We obtained 68% of top 3 accuracy, which is pretty high. And like the business benefit of it is more accurate tagging and more convenient search through the categories. Now, the last but not least part of our project is generation of book description. There are a lot of NLP pipelines and approach that could create beautiful results, but the vast majority of them tend to work with small texts. So it's really hard to process a 300 pages document to extract some, to make some classification or so on. So there is a crucial task of extracting the most crucial, the most important information out of the whole book, and to make it more dense in order to apply some another NLP approaches further. So this part consists out of 3 subtasks. It's book summarization, It's keywords and hashtag extraction, and it's actually name identity recognition, finding names, locations, and organizations. So let's consider them. The first one is book summarization. It's really hot topic in NLP. For example, Google Brain now publishing a lot of papers about it. So yeah, we used BERT-based architecture provided by Facebook and implemented book summarization page by page. And here we could see some input. There is a long text that could not fit this slide. And at the output, we got a pretty small paragraph that captures the main ideas, main names and concepts, and it could be used further for another NLP pipeline. Yeah, another interesting part is keywords and hashtags extraction. This could be crucial also for searching for interesting books. For example, one could want to find something about Союз незалежних українців. And with this mechanism, we could extract these keywords from every book and allow user to navigate through these hashtags, maybe filter something or filter something out. And in that way, it also provides a better user experience. Also, it's a really convenient tool for further analytics and some EDA. And the third part is extraction of names, locations, and organizations, which is a classic name identity recognition approach. We also used transformer-based architecture here. And as you can see, results are pretty good. We are identifying organizations like Союз Українських Незалежників. We identifying persons, locations, and so on. So this also could be used to create a set of search concepts, tags, and so on. So to conclude, we developed products that could help customers to read books in the way that are more convenient to them, with TXT files or whatever they want, without yellow pages, and with ability to highlight text and so on. Also, we are providing a product for the maintainers of the library, allowing them to manage the library more efficiently and to create tools for users that will allow them to search through books and to see books that are most relevant and interesting for them. That's all. Thank you for your attention.
Thank you to the team Dead Poets Society. Let's give the team the virtual round of applause. Thank you. Any questions for the team? And okay, I can start while you think. So as you develop a product, so do you have a prototype of the product that you can show, or it's basically, yeah, did you try to create a prototype, and if yes, what are the capabilities of the prototype that you create of this product? Especially, at least for me, it's interesting the book digitalization part.
Yeah, as for book digitization, I would say we have a strong POC, but there is still like a few steps I would prefer to make before calling it the MVP, because we need also maybe to implement a bigger vocabulary. As you can see from the presentation, it works really great for common words and for like general sentences. But when we are talking about some old books with some specific vocabularies, with some maybe really difficult words that are not as common, for them we will need more sophisticated vocabulary to not to mark as errors just very specific words. So I would say that now we have a product that works well on general texts, but if you're talking about some really like good literature with great vocabulary, I would say that we need to add greater vocabulary to fit with it. So there are still a few steps before calling it MVP and processing the whole books to like process the library.
But can you show maybe one book that you converted to the EPUB format and how you can basically read it and interact with it on I don't know, on your device, on electronic book reader or in any program that supports EPUB. So even without the error correction. So let's put aside the error correction. Can you show an example of a book that you digitized in your product, then somebody can put on their electronic book reader and read?
Yeah, we have some TXT files, and I think I could just send maybe some screenshots or something like that after the presentation. We have like a collection of TXT files that were processed by OCR and also like post-processed, and some errors were corrected. Yeah.
Yeah, and this is more suggestion for the Tula competition. So
okay.
If you show on an electronic book reader or on a simulator on a screen a short, whatever, 20-minute video where you read the book, you go from a chapter to a chapter, you search for something and stuff like that. So basically, what will be the end result of this book digitization product, which is the book that you can read on your own device. Thank
you.
Okay,
yeah, sure.
Yeah. Other questions for the team, please? Yeah, Taras.
Thank you for presentation. It was interesting. I have two questions, and both are about Levenshtein distance. First, I would like to ask whether you looked over what are the most popular mistakes in the books, and do they have some specific? Because Levenshtein distance is based on substitution of letters in the word. And it will find like the words that will have the minimal substitutions of letters with the given that has some mistakes. When I was looking at the mistakes of the OCR after applying Tesseract, I found that most of the mistakes were not about that some of the letters were substituted, but because one of the letters was incorrect, but other letters were at the correct positions. And one of them, it was just different. It should be like or instead of or something else. So that's why asking whether this metric is the best choice here, and maybe you were thinking about other like alternatives or.
Yeah, thank you for your question. Well, Levenshtein distance is not only about like adding or removing symbols, but also about changing symbols. So as you mentioned, the most common mistakes are when one or two letters were incorrect, they were missing, they were some additional letters, or they were replaced by, like they were recognized not in the right way. And all these three cases are coherent with the small Levenshtein distance, because all the other letters are on their places, and we have only this problem. So Levenshtein distance works really well here and allows us to propose a set of words that are close, and usually in most cases the real word is in this set, and then we could use the BERT to find the most semantic appropriate.
And another question about it is that not computation of Levenshtein is not very parallelizable, and if you have a lot of like mistakes in the text that you should correct, how long did it take to correct the mistake in a single book, for example, to find the distances to all the words, Levenshtein distance to all the words for a single that has a mistake?
I would say that it is actually parallelizable, because we could read every sentence separately, and book could be like processed on different devices. And actually, it's not as long time. I would say it's a question of a few minutes. And also, like an author spent maybe years creating a masterpiece. Probably we could spend a few minutes processing it for the best user experience of readers. So I think the time is not actually crucial parts here, because like there are many clusters and there are like not as many books to be processed. So we could, I think even on computer, the same as OCR, that we could use on cluster or use like just take a little longer time on personal computer, the same way we could use this post OCR.
Okay,
it's
so
it's comparable time, yeah.
It wasn't a bottleneck in this.
No, it wasn't a bottleneck.
Okay, thank you.
Any other questions for the Dead Poet Society team? If not, thank you again. Thank you to the group for the presentation and the decision to create a product for the tool library. And now we are moving to the presentation of the last but not least of the team 6, Genetics. Please.
Yes, hi everyone. Let me share my screen. As always, just a moment, I need to allow my Mac to share the screen.
Yeah, take your time, no worries.
Yeah, I'll be in a second. Yes, I am back. So do you see my screen?
Yes.
Yeah, so this is Andrei from Genetics. Here we are with Victor, Alex, and Dmitro. So basically, our team had two directions in which we made our researches. Victor, Alex, and I were working on one direction, and Dmitro was working in another. We will start from the first sub-team. So we were thinking how we can, basically help Tula, and we asked ourselves two questions. So how we can help Tula and how Tula can help others. Basically we can make some research for Tula and have some insight, and then Tula can help, for example, researchers or students that are studying Ukrainian language. We created a concept. It is not a solution because we didn't code it, but we tried to create researches on how this concept could work. And the concept is the following. It's like online spelling vocabulary. So where you can search through a specific word, and it will show you the books that Tula has and where this word is. For example, this is completely fake word and fake books, but this is how it could possibly look like. So for example, we are searching for a telegramma word, and it shows that we have two occurrences, or basically four occurrences, but in two books, sorry. And the other thing was to show how this word changed during periods of history. For example, how it was used like before some spelling changes. For example, this was in the Soviet era. This is fake. And another is a sentiment analysis. So the user could see how this word was, in what context it was used, speaking of sentiments. So, for example, if it was positive or neutral. And we will try to explain how our researchers could possibly help to create this kind of platform, which Tula could possibly then use to create some benefit for them. So as always, some ideas have some story background. I wasn't originally doing something about that, about this research. I was thinking about my grandma. Well, when I was a kid, she was visiting us, and she always told me that you need to study because I didn't have this opportunity, and she said I already only studied 4 grades. And the way it sounded, it wasn't like we said it in Ukrainian, like я вчився в 4 класі. She said it like я закінчила 4 класи. And I didn't thought about that until, I guess, when we start working with Tula. So I always thought that the way she was telling me that was because, well, she lived close to a Polish border, and I thought it has some influence on that, or maybe because it was German occupation, but it wasn't, I guess, the correct question that I was asking. The correct question was why it has changed to the other form that we use, like not class, class. So the question that I asked myself was how Ukrainian language changed or was changed during the Soviet era. I was looking through the Tula, and I found one spelling vocabulary. I have the author in the my report, but I forget it. It doesn't matter. And it was written not in the Soviet Union, but it used this old spelling grammar, and I found this particular word that I was speaking and class, and it was there, and I sought to research on how and when it was changed. So, and well, it was changed. It was changed in 1933. There was a Soviet rule at that time, and they tried to close the gap between the Ukrainian and Russian languages, and they did some changes and changed a lot of words, changed several letters, and I tried to find out how we can determine whether this book was written under Soviets or outside, maybe in diaspora. And the first thing that I saw was letter G and H. So in 1933, letter G was completely removed from the books. And the only book, the only letter that was used was H, and a lot of books will show like 0 of this letter. I'll show in the numbers that I got. The other thing was that I was working was target vocabulary. So the naming may not be right for that. I will still work on that, on this naming. But I was thinking to create a specific, my own vocabulary of pre-change words that will help me to determine whether the book was written in specific era. So I was at that moment more of a bookworm rather than data scientist, but so I downloaded several spelling vocabularies and was searching like the state of word and how it changed, and I chose approximately 600 words in different forms. I'll get to it just a moment. So some words may have the like the lemma could be changed, but other will be the same, or endings could change. So different forms are required for this approach. Also, a lot of words that are coming from the books that I analyzed had errors, and that's why the results I'll show you. Well, let me show it. And so there are some figures. I tested the 51st books, and as you can see, if I compared against my vocabulary, I had only 136 occurrences of specific words. For STEM, it was 70. Well, I guess it is because of the bad quality of the text, and also that my vocabulary wasn't that big. And as you can see, the G letter was a lot more, like 10 times more than other approaches, because well, basically, if you compare a word to word, like string to string, you sometimes get an error. But when you are searching for a single letter, you most likely will find it in the word, or even some words can have multiple of these letters. So these were the approaches. There are other rules that I tried, like checking the suffix or prefix, but their results were, I don't know, approximately 10 occurrences for 50 books, and I didn't include them because it was too less, maybe an error. Yeah, so that's it for my part. Victor can continue.
Hello to everybody. Please, next slide. So, I was searching for the ideas, and I started to discuss with my friends. And first of all, I started to discuss this topic with the founders of so-called YEMOA. This is a group of people who already years developed the Ukrainian, and they are also the professor of Kiev National University and other. So their idea was the next. It is very interesting to compare the original text and text that were published in the Soviet Union and in modern Ukraine, and to understand and to analyze what the Soviet Union changed the language and then changed the mentality. So I decided to help them with this, and the focus was very specific topic, and to try to solve this question for them. So next slide, please. I decided to work with text of Volodymyr Vanechenko. He was not only the poet, but also one of the greatest historic person of that time, and also was one of the author of all the declaration of Ukrainian state of the time. So, and I want to decide whether the text that published at that period and modern are similar. What I find out that and the biggest restriction was the poor quality of text that already mentioned colleagues previously. To increase this quality of text, I'll try to use some algorithm, very simple, and then I understand that it is not possible to solve this problem at all, to give the high quality text because of typos, because of not quality scans, and so on and so on. I work with two texts, Fedko, Chlamydnik and Secrecy, and could you please give the next slide? What I did, I tried to use some algorithms, two algorithms, Redcliffe, Oberhof, and causal similarity to check the text. After the computer increasing of quality, the score was around 60 with maximum score. After the mutual correction, it will totally increase. Why? Because there are a few problems. First, this typo. Second, there are not correct wordings according to the scan, and so on. So I use a different model to try to manually solve this problem. And you saw at the screen that this model can help
not only me to solve this problem, but can be very simple mechanism to the scientists who try to understand whether texts are similar, and they can understand what to solve, what to do in the text. Why it is important? It's important because if you don't have a correct data or correct text, your result will be unreliable and not adequate. Please, next slide. If I compare modern and original text, I mean, in this case, you saw the result of text so-called Fedko-Chlamydnik. I calculate different words, statistical, language, letters, statistics, but you also try to find out the words that was typing by different ways. So you see the most frequent, which compares the original and modern, and as already Andrei mentioned, Slovo telegrama with one of the key words that mentioned there. The most proper and most pattern was through EI, CC, and GG. So I identify 45 different patterns on this, and so on. So the results you are able to see in the slide. Next, please. The same things was with letters and symbol. It is very interesting because you can see the increases letters of R and decreases letters of V, like Skolik comments that it's one of the things that it is very interesting to further analyze why these things is going on. Next slide, please. I try to visualize the words that are different in both texts in the original and in the modern by two types of texts, full text, and also the second one is excluding the stop words using the Sergei Kuprienko's vocabulary. And the next slide, please. As a result, we'll receive the automatically generated report with all statistics, with word cloud, and also the Excel file with statistics, with letters and symbols which are different. And then you as a scientist can analyze this text or other texts, combine it, and make further analytics in your research. So I give the words for my colleague.
Alex.
Yes, can you please the next slide? So I will talk a little bit about sentiments analysis. For the slide, I took the book Мівіндорські і літопис спогади і записки by Oleksiy Kosikovsky. So first of all, we want to understand emotional condition for coloring of the single page. In other words, is current page about something sad or something positive or just natural? And then we take all pages as sequence to understand the order of emotions in our book. And finally, to understand, is it a sad book or positive? Also, if we consider more than one book from specific, also we can determine his own style of writing. So we see that current book has positive and natural sentiment during the whole book, but with some very negative, sad moments. So next slide, please. N-grams. N-grams is continuous sequence of n items from a given sample of text or speech, in our case from that text. So N-grams is very powerful and simple tool for sentiment analysis or even brief description, text summarization.
So we take a look at our n-grams. In our case, 3 grams on the left side and b grams on the right side. In g grams, we have Українська католицька церква, Windows Daily Star. It's a newspaper in Canada. And in b grams, we have Олекса Косіковський, філія УНО, це Українське національне об'єднання в Канаді. Again, Daily Star, Maria Kosikovska, maybe Alexa's wife. So n-grams often show the names of main characters, common phrases of those time, location, organization. So it's a very powerful tool to analyze the whole text. So Dimitro.
Yeah, so the next slide. So I decided to choose another problem. As Tula stated, one of their problems is to bring new people to Tula and to Ukrainian literature. And right now, nothing attracts people as much as AI-generated arts. So my idea was to implement an AI illustrated book. For this purpose, for this task, I decided to take one book and to create a proof of concept that it's possible. So I decided to one of the best adventure novels in Ukrainian literature, the Tigrolovi. And yeah, so the next slide. Yeah, so here you can see several examples. There's a short description what are they showing, but yeah, they were generated just from raw text from the book. So a short explanation how it works. I was also using the Clip and VQGAN combination of models. The limitations I had was computational resources, a good zero-shot quality, and not scary results. Like I will tell about it a few moments later. Yeah, so the way the VQGAN and the Clip works is like Clip is a model that can bring the text and the image to the same vector space. And the VQGAN is a generated model. It's some kind of tame transformer, adjusted tame transformer and speeded up tame transformer using quantization. So it's very useful for image generation, because like in this approach, VQGAN like makes lots of computations, and using just simple tame transformer would be like too computational powerful, like too complex. So yeah, quantization helps a lot here, and the way it does Clip is just getting the image the VQGAN returned you, and it's saying how good it is and how bad it is. So it's like accuracy metrics for VQGAN, and it's like guiding VQGAN towards a more and more accurate image. The problems I stumbled were like the text size limitation. It was about 70 symbols, I believe. And yes, there were two approaches I was doing it. It was selecting some kind of text parts that are quite describable, that are easy to illustrate and that not so big. And if, for example, I'm using, there is some description of nature or description of some kind of situation, and it's like, for example, 1.5 page, I used the algorithm Alexander provided me with the text summarization, and it also proved to be working. Yeah. So the other options I've next slide, please. Yeah, the other options I tried to use, the other models I tried to use, it was the Siren and the DALL-E models, but like they were a bit too realistic, and that was a big problem because like we know when scenes are too realistic and they're like us, they are scaring people. So, and Wikigun and Clip was showing some kind of fairy tale results. And yeah, it's a bit impressionism. So I would call it neo-impressionism style. And like everyone seeing this picture were impressed. So here is it's a GIF. It's like iteration, like what images are adjusting with each iteration. So each image was about 250 to 300 iterations, I believe, as I didn't have too much resource, but computational resources. Yeah, so the next slide. Yeah, so a bit conclusion about image generation. Yeah, as I've already proved, it's totally possible to create illustrations for a book, and they're like attracting people. Everyone I showed them, but like, wow, that's fantastic. Also, it's like easy to make a viral news, like post it on some Twitter, Instagram, or so on, and it's like would be viral, and lots of people would come there and see. They would like to come there and see this book, and so it's a big traffic generation for Tula. Also, this algorithm can have a further development. As I already said, right now, the text pieces to illustrate are now selected by hand personally, and it's very implementing an algorithm that can find our text pieces that are nice to illustrate, that have lots of illustrational meaning, would be great, and will enable us to create fully automated illustration algorithm for a book. Yeah, and also it's possible to like gather all these images and text back into a book, for example, to create a EPUB or some kind of printed version of a book. Yeah, also this is an example. We can generate, we can collect all these illustrations all in one page with this kind of collage, and use it as an and title image for the book. Yeah, so thanks for your attention. Next slide. Yeah, thanks for your attention.
Okay, thank you so much for the presentation. Let's give the group Genia Pigs a virtual round of applause. Any questions? I'll have to drop right now because I have the call at work that started a minute ago, but feel free to continue for another 5 minutes if you have any questions for the group Genia Pig. So I just want to thank everyone for great projects and presentations, and I hope that all of you will decide to participate in the Tula competition, and eventually some of you may decide to make those as a research project, so master thesis projects, or really apply for the grants and stipends from Tula or any other sources to continue these great ideas that you presented today. Okay. Any questions for the team? Okay, if not, let's wrap it up. Thank you so much for everyone. I hope that you learned. Alexei, questions?
It's not rather a question. I just want to add at the end of the presentation. So thank you so much, guys. There was really interesting to hear your results, seeing your teamwork. I just want to suggest you to make some shift in terms of presentation when you will present your results to Tula, to make them more business oriented, not that technically overloaded. So show them like end user results, and to be more user oriented, if I may. So it's only this kind of suggestion. Thank you.
Yeah, thank you, Alexei. I will definitely support this. And if you want to discuss while you prepare for the Tula presentations, feel free to reach out to me or to Volodymyr to have these discussions. But otherwise, yeah, thank you for taking this course. Definitely don't hesitate to message on Slack or by email. And yeah, good luck with your future studies. And thanks a lot for really all the efforts that you put into this course project. Thank you. Stay safe and healthy. Bye-bye.
Bye.
Thank you.
Thank you.
Bye. Thank
you.
you.
Bye.
Have a